Hello everyone, today we're going to be reading about humidity. So humidity is the measure of water in the air. Now, of course, we're talking about water that's normally a liquid, but in the air it's not. In the air we're thinking about water as a gas. So thinking back to our chemistry section, when we're thinking about water as a gas, it is fast-moving molecules. They will take on any shape of any form of any container they're in. The gas molecules are not really connected to each other. They're not interacting with each other. They're usually moving too fast to interact with one another. Now, in the case of clouds or fog, then we're talking about water that's moving slower, and those water molecules are moving slow enough that they start to interact with each other, and they start to collide and connect with each other, and that's when they're kind of a liquid droplets floating in the air. And in that case, a cloud or fog is actually not invisible. A true gas should be, is mostly invisible unless it's one of the colored glasses, but water as a gas is invisible. The molecules are moving too fast for light to travel through in a way that changes its color effectively, give or take. So imagine having a block of air that has a mass of 1 kilogram. There will be some water molecules floating around in that air. There's always a little bit around our planet. Not a lot in some places, like a desert, and in other places there's lots, like in a tropical rainforest, for example. If there's lots of water molecules, we say it's high humidity. If there are very few, then it's low humidity. Here's an example of what that might look like. In a kilogram of air, if you had all these water molecules, they're floating around, that would be called high humidity air. Low humidity air would be not very many. During the winter, we usually have a very low humidity because it's so cold that there aren't very many water molecules that aren't in the form of ice and on the ground as snow. In a summer situation, especially in Manitoba, we will have a lot of water that gets evaporated by the high sun. There's lots of sun during the day in Manitoba, and so that lots of sun will evaporate lots of water, and that water will be in the air as a vapor or as a gas, and that water vapor will make the air feel very thick and very dense, and that's a high humidity day. Now, these are, of course, relative to Manitoba. There are places in the world that have much, much higher humidity, and even places that have much lower humidity, depending on the location around the world. So instead of counting molecules of water in each kilogram of air, because that would be billions of molecules, it's billions upon billions, the amount of water in the air is often expressed as grams of water per kilogram, and this is known as the absolute humidity. However, in everyday conversation, we don't usually say, today really feels like 23 grams of water per kilogram of air today. So instead, what we do is we usually talk about humidity as relative to other times of the other days of the year. So we might say that, or relative to other conditions. So the meteorologist will report that the humidity is at 37%. To understand this, we need a little bit of background. One thing is that that air at any temperature acts like a sponge. It'll suck up a certain amount of water. And when that water exceeds that certain amount, it will start to drip out as rain or dew or condensation. So one of the reasons that dew forms in the morning, so overnight and through into the morning, is that that during the day the air fills full of water, and then at night the air cools down. And so as the air cools down, it can no longer hold as much water. So for example, given the air right now, and we're in a zone where during the day our air could be as high as, say, 18 or 20 degrees Celsius, and so we could be holding about 15 grams of water at a maximum. In a very humid day, we might have 15 grams of water in the air. But at night, the temperature will drop down maybe to 8 degrees or so, and suddenly the air can only hold 6.8 grams of water. Well, that means that there's about 10 grams there of water that has nowhere to go except to become some sort of condensation. And that could be the dew on the grass. So if you wake up in the morning, you start walking very early in the morning through the grass in your bare feet, you'll see them get soaking wet very quickly, or you'll see water form on your windows maybe in the morning or on your car. So that is because that during the day when it's hot out, the air can hold a lot more moisture than during the morning when the air is much colder. So cooling the air is like squeezing out a sponge. The table at the right shows us how many grams of water each kilogram of air can hold at different temperatures. This is a table that you'll use in a couple of different experiments or different questions. The air that is holding as much water as it can is called saturated. So when you actually reach that 15 grams at 20 degrees, that is saturated air. It is air that has 100% relative humidity. So this is also known as 100% relative humidity. So if they ever say that the air is going to be close to 100% humid today, then that means that we are getting close to that extreme limit. So why did the outside of mugs at A&W end up covered in water, especially during the summer? So I don't know if you've ever gone to A&W, but if you eat inside their restaurant, they'll often serve their root beer in a glass mug. And these glass mugs are cooled in a refrigerator so that when you fill them full of the drink, it keeps your drink cold. But one of the things that happens on the outside of the glass is it gets very wet and cold, and it might even get frosty. And that frost is because the air molecules, the air around the mug is going to be losing its heat as it tries to warm up that glass. And so then the temperature of this air here, I'm going to put a little temperature, is going to be lower than the temperature of the air a little bit farther away. So the air over here is going to be higher. Should probably use two different colors, right? Okay. So let's put the air here and the air down here. So the air that is very close to the glass is cold. The air that's farther away is warm. But the amount of water molecules, let's maybe make them blue. The amount of water molecules is the same everywhere. So that means that the amount of humidity that can be held by the water that's close to the glass where it's colder is lower. And so the water molecules that are in all of the air around the A&W restaurant, some of those water molecules are going to start to stick to the side of the mug, and you're going to get this condensation because the air can no longer hold those extra water molecules as they are close to this cold mug. So the colder air cannot hold as much water, so it becomes a liquid condensation. So the relative humidity compares the amount of water that is actually in the air to the maximum amount that it could hold at that temperature. In other words, it tells us how full the air is. For example, a relative humidity of 75% means that the air is 3 out of 4 full, so 3/4 full. Relative humidity is kind of like a gas gauge on your car. So suppose that the air at 20 degrees contains 12 grams of water in each kilogram. What is the relative humidity? Well, let's think about it. At 20 grams, you could hold 15 grams of water, but you are only holding 12. So out of the gauge of 15, you're holding 12, so we can divide those two, 12 divided by 15, and then multiply it by 100 to make it a percent, and you're going to find that there's only 80% of the water. So two numbers, you're going to look for the number on the table, so this number comes from the table, and this number comes from the question. Okay? So on a sunny day where the temperature is 24 degrees, the air is holding 11 grams of water. What is the relative humidity? So we need to go find the table way up high and find 24, the temperature of 24, it's 19.2. So I'm going to take 19.2 grams. So this is from my table. This is from this other one is from the situation. And we're going to multiply that by 100%. And so I'm just going to pull up a calculator here and go clear 11 divided by 19.2 times 100. Watch out with that percent button. That percent button does something different. If you're doing multiplying by 100, that's fine. I've already done the work. So 57.3%. That would be the humidity. I'll give you the other questions to try on your own. And I just want to make our connections at the end here. How does sweating keep us cool? Well, it takes energy to evaporate the sweat, which it absorbs from our body, leaving them cooler. But that evaporated water goes into the air. So the sweat goes into the air. Now on a muggy day, so a high humidity day, where humidity is very high, the air is close to saturated. Sweating does not work as well during those days, and you can even have heat exhaustion or heat stroke, which are real dangers. You can feel really ill after those. So what's happening is that when the humidity is high, the sweat cannot enter the air. The air is already full. The gauge is full. You're already at 99% humidity. So there's no more room for the water that's on your body as sweat. And so without evaporation, the sweat is actually going to work to keep your body warm because the sweat has a high heat capacity. It can absorb a lot of energy. And it'll prevent the heat from normally conducting off of you. That's why you might be able to cool yourself down in a hot, sweaty day by wiping the sweat away from your forehead and letting the cold air and wind or a fan blow across your skin. And then without the sweat there, your skin will be able to conduct directly to the air that's being blown on it with a fan. So when it's hot and humid out, you want to try to keep that sweat off your body to cool yourself down faster with wind from a fan. All right, hope you enjoyed that video, and we will talk to you in the next one.